This is a tutorial video showing you how to do Recon against websites and DNS-enabled servers using Kali Linux. If you go to my GitHub account, you'll find a gist here, which lists all of the most commonly used tools and systems in Kali Linux to do Recon. So you can find that under github.com, username Apollo Clark, and look for the recon tutorial.md. Keep this open in the background as we're going through the tutorial, so that way you can copy and paste the commands to the command line. So open a terminal window, type clear, type ifconfig space -A. What this will do is show you a list of the network devices for your computer. Now, usually one device will be the LO, the loopback device. This is on every single Unix and Linux machine by default. It just means a local network connection. Doesn't actually do anything. It's just used to talk to yourself. And if you do have an internet connection of some kind, you'll usually see either one called ETH0 or one called W1P1S1. This is the initial and first Ethernet or Wi-Fi connection available to the device. So with this one, you can see I have one called ETH0. On the next line, you'll see the INET, the internet address, which is the IP4 IP address. This one's 10.02.15. And because I'm running Kali Linux in a virtual machine, this number should be the same for everyone else that does it this way too. You can also see the Internet 6 number here, as well as the MAC address and various other pieces of information about the network connection. So to verify we're online, we're going to type ping, P-I-N-G, space, google.com, enter. And what this will do is send a ping command over the internet to whatever address you put into it. The ping command by default usually hits port 80 and is a very simplistic command. It basically just says, are you alive? Do you exist? All that. Now, sometimes if you're running a virtual machine, it doesn't always turn on immediately. So let's try that one more time. All right, there we go. So you can see here, as I'm running ping, it'll hit the google.com address and come back to me. So we press Control-C on the keyboard. This will stop the command so we can actually look at it. So you can see here we put 64 bytes from our local address. And we're hitting the IP address here, 172.217.314. You can also ping 8.8.8.8. This is the one of the DNS servers that's run by Google. And this one should always run, should be really quick and fast. So if for some weird reason you can't do google.com, try pinging 888. All right, Control-C, stop that. Next up is when you're doing recon on your targets, you want to get a sense of what's out there, what they're running. So in order to do that, I want to show you how to look at your local system to understand what's running locally. So that way, when you're looking at remote services, you'll kind of get a sense of what's going on there. So the first command we're going to run is PS. And this is built into Bash. It's a very old, Unix command. It basically just lists off the processes. If you want to learn how to use things in the command line, just type man space and whatever the name of the program is. In this case, PS. So we type man space PS. So there we go. Report a snapshot of the current processes. There we go. Displays information about a selection of the active processes. If you want a repetitive updated selections, use top instead. Blah, blah, blah. Go ahead and press Q, and this will exit out of this. All right, clear, enter. Going to run the command ps space AUX. And I run this command all the time, every single day, left and right. If you scroll to the top of this command, you'll start seeing here we have the user, the process ID, the percentage of CPU memory. I can't remember what VSC or RSS actually stands for. TTY says this is a interactive terminal. You can do stats, when it was started, how long it's been running for, and what the actual command is that's running. And the vast majority of these, you'll all notice, are initially running as root. You can see the process IDs are sequential, 1, 2, 3, 5, 7, 8, 9, 10, 11, 12. And basically all these ones up here are just system services, things that the system needs to run and operate. And, every This Kali Linux is based on Debian, so all of these services you'll see on basically every machine. One that's kind of interesting here is the VBox service. This is being run because I'm running this inside of VirtualBox, so this service will naturally start up in the beginning. And as you scroll further and further down, you'll see things like Xorg, GNOME, GDM3, and these are things for your graphical interface. Those are coming up. Here we go. We got the VBox client, various services from VirtualBox. There we go. Got a couple GNOME shells. Got a little Python 3 running in there. You go way down the end, you can see here, here's the actual bash. This is the process we're running right now. Iceweasel, which is the browser in the background. So this gives you a sense of what is your system actually running. So let's go over the command again. So it's ps space AUX. The A command displays all processes, including those run by other users. In this case, by default, using the Kali Linux VirtualBox, you are root, so you'll see everything. U display user-oriented format. So if you type PSAX, it's a little more difficult to read. So that's why I usually type PSAUX a lot. It's a little easier to read for the users. X display all processes, including those that are TTY. In other words, also show the services running in the background that don't necessarily have a command line shell you can initially talk to. So if you type PSAU, you'll notice this list is a lot shorter. It's because it's not showing all of the system services. So that's how all that goes. You can see each time I run it, it gives you a slightly different variation. The command PSAUX, that's a pretty universal one. If you do any kind of system administration in Linux, you run this thing all the time. So this just shows you what's running for programs on your system. Next up is we want to check the firewall settings. So we're going to use IP tables space $ capital L. So if you want to copy and paste this, you press Control-Shift-V to paste it. And there we go. So you can see by default, Kali Linux doesn't actually have IP tables set up. On servers, usually you'll have IP tables set up to configure things like where is the information coming from, where is it going, what protocols, is it TCP, UDP, what port numbers, priority. It's basically just setting up a system-wide firewall. So you can see here we don't have anything there, so I'm not going to worry about that. But again, it's a good command to know how to run. Next up, we're going to look at Netstat. And if you want to, you can click that extra link right there. It'll show you the man page for Netstat. Netstat will show you what programs are running, but also if they're bound to a port. So when you're running a service, it really isn't that different than when you run a, like Notepad. It's just a program. What makes a server different, though, is that the programs you're running tend to be bound to a port number as well. So that way they can listen to remote user requests. So type netstat -tunlp. I usually just say tunnel p. Press enter. And there we go. So we have one program running here, which is DHC client. If I remember correctly, this is used by Debian to do like really simplistic file sharing. Sometimes when you run Netstat, you won't actually see the program name, and that usually means you don't have admin level access. So what you can do too is type sudo netstat -tunnelp, and every now and again the results will be a little different. But in this case, we're already the super user root, so we already get all the information we want. Yeah, so here's Netstat. You can see Netstat has a ton of commands, probably somewhere around 110, 120 or so. I don't really use most of them. You just got to know the basics, which is what tunnelp does. So you can see tunnelp is actually shorthand for running all of these different command flags. So T just says show as TCP, U says show as UDP, N says list things in a numeric fashion instead of alpha or hex. -L says show only listening sockets. So sometimes you can be a program that's running and is bound to a port but isn't actually listening. That's usually used for things like VNC clients, because they're not going to listen to remote connections. -P is really useful. It shows the name of the process ID. So that way you can say, okay, this program on this port is DHC client bound to port 68. So that's how you look at your local system and say, what programs are running, what are my firewall rules, and which programs are listening for remote connections. So if you look at the Netstat output here, you'll notice it says 00000. This basically is just shorthand for saying listen to everyone anywhere. So you can have some programs that are running and bound to a port, but will only accept local connections on 127.0.0.1. In other words, the loopback interface. So this is good if you want to run a server locally. So sometimes I'll run things like Postgres for a database, and I only want it to listen to my local connections and not the open internet. So you can run programs to only listen to yourself. It's a very good technique to use if you're setting up servers for the internet. All right, so next up, we're going to use Nmap. And if you ever watched The Matrix, there was a scene where Trinity was quote unquote hacking into the Matrix and the servers, and she ran Nmap to look at what was going on in the system. So we run Nmap space -VV space -O space -pn space -lowercase s uppercase tuv -- top ports 1000 127.0.0.1. Again, a lot of features and options here for this, but don't really worry about that. Again, I'm just going to show you the ones that I most commonly run. And honestly, I've never even used all the options in Nmap, even though I've been doing it for like probably 12 years now. But anyways, so what this command will actually do is the first section says be verbose. In other words, show me all the output. You have a little detail. -O says enable OS detection. In other words, try and figure out based on the port scan what operating system this is. Is it Linux? Is it Windows? Is it Ubuntu, Debian, Fedora, blah, blah, blah. -PN, it says treat all hosts as online. This is a little more useful if you're scanning multiple targets. In this case, we're just scanning ourselves here, 127.0.0.1. But any other time when I'm doing a port scan, I always enable PN. The -STUV, this is actually shorthand like we did with tunnel map for Netstat. It's actually a combination of 3 different commands. One says when you're doing the port scan, do a TCP connect scan. I think there's actually 5 different TCP scans. Connect, that's a standard one, just go with that. Also run a UDP scan. And SV says probe open ports and try and ask what is the service running and what's the version number. You'd be surprised. A lot of services running on the open internet will actually tell you not only that they're there, they'll say they're listening, they'll actually tell you what they are. You know, is it Postgres, MySQL, Apache, Nginx? And amazingly, by default, they're actually configured to tell you what version they are, which is a really, really bad thing for security because that means I can go and say, okay, you're running version, 5.1.2 of MySQL, and then I can just go and Google for exploits against that version of MySQL. And if it's more than a year or 2 old, I guarantee I can find some exploits. So you can find a lot of really low-hanging fruit with this. Now, you can scan every single port, which is around a little over 65,000. It's, what was that, 8 to the 12th power, I think? Somewhere around there. Or 8 to the 16th. There we go. So you can scan all those ports, but it's pretty slow. On average, on the public internet, depending on your connection, the server's connection, and various, latency issues you may run into on the network, it takes anywhere from 15 to 25 minutes to scan every single port for TCP and UDP. I do that when I'm doing any kind of engagement or when you're doing the OSCP training itself. But generally, you want to kind of save yourself some time. If you're scanning, a lot of targets, you don't want to sit there and have your computer run all day long. So instead, initially, just scan the top 1,000 ports or the top 100 reports. I find the top 1,000 ports scan runs in about a minute or so. So let's go ahead and do that. So copy the command, Control-C, Control-Shift-V to paste it. Sometimes you'll actually get a permission error when you run Nmap. So sometimes you got to put in sudo in front. So let's go ahead and do that. And the last number here, 127.0.0.1, this is our target. And in this case, we're just going to scan ourselves. So let's go ahead and let that run. All right, cool. Now that the scan is finished, we can go ahead and scroll up a little bit. So even though we were scanning ourselves and only doing 1,000 ports, you can see this takes about a minute and a half, sometimes 2 minutes. So scroll all the way to the top. You can see here, loaded 35 scripts. Nmap itself does allow the use of scripting. So there's a couple of them that are enabled by default. If I remember correctly, I think Nmap is using Perl as a programming language. So that's pretty interesting. So you can see here we're scanning our ourself, localhost, top 1,000 ports. You can see the scan here. Took about 1.28 seconds to start. Started scanning, did the scan, blah, 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 blah. Yeah, it took about 90 seconds total to run. Tried doing OS detection, really couldn't find much. Let's see what else here. And then here's the real one right here. This is saying what are the ports, what's the state of them, what's service, what's the response from them, what's the version. So you can see here we found port 68. It is running UDP. It is open and filtered. It is telling us what the service name is, in this case, GHCPC, but it doesn't give us a reason or what version it's running, which is fine. And sometimes gives you a little fingerprint. I don't really ever use that. So that's cool. So we can at least verify that we have port 68 open. So that sounds pretty good. So what we're going to do next is we're going to start the service Postgres. This is just a database service. This is installed by default in Kali Linux. So if you type sudo service Postgres SQL, type just do restart just to make sure everything works. And what this will do is go ahead and run the Postgres service. So we're going to do is verify it's running by doing ps-aux, which we did earlier to show the process list. And we're going to pipe that over, which literally just means take the output and give it to another program. We're going to use the grep command, which is a text searching command. And we're going to look for Postgres SQL. All right, cool. So you can see here, here's the Postgres service being run as the Postgres user. Coming out, Postgres 9.5. All right, cool. So we've run the Postgres service, and we can verify it's running as a process. And we can also type sudo netstat -tunnel p. And there we go. We can see we have Postgres. You'll notice there's two entries here. One of them says TCP, which is what you would expect. And this is allowing connections from any remote address to localhost port 432. You'll also see there's a TCP6, IPv6 connection, which is also listening on port 5432. And you notice here it just says :::::::. That's just shorthand for IPv6 0000000. All right, cool. So let's go ahead and do another scan of ourselves. And we should, Nmap should start seeing the Postgres service running in the background. Again, let's take about a minute and a half. All right, cool. So that scan took a little bit faster, which is nice. Scrub a little bit. And boom, there we go. So Postgres 5432 TCP open Postgres. Did a SYNEC against it. You can see here it says Postgres SQL. One service unrecognized despite returning data. If you know the service version, please submit the following fingerprint, blah, 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 blah. All right, cool. So yeah, you can see they're not shown 9999 closed ports. So that looks pretty good. So we can actually see from the outside potentially that we're running Postgres. Cool. And you can do the exact same thing against a remote service. All you do is change the IP address at the end of the command. You can also pass in a range of IP addresses. All right, so in a nutshell, the way that your computer talks to remote services on the internet is your computer talks to the router. Could be the Wi-Fi router, could be the hardline Ethernet. Your router then talks to your ISP, be it Comcast, Verizon, Time Warner, whatever, and they will take the command, for example, if you did google.com, and the DNS will convert google.com into the IPv4 or IPv6 address. Then they will talk to another router, which will send it around the internet, figure out where it should go. The server will see the request, generate some kind of response, and the entire communication will go backwards. It'll go back to the router, back to the DNS, and to your computer. And that's basically how the internet works. So what we're going to look at next is how DNS itself operates. So if you type dig-t space any wikipedia.org. What this will show is what your computer and what the internet itself sees whenever they try to contact wikipedia.org. All right. Scroll up a bit here. So you can see dig 9.9.5, Debian trying to talk to wikipedia.org. Blah, 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 blah. We don't really care what the question is. We already know what the question is. We're saying, give us a list of any DNS entries you have for wikipedia.org. And the response selection includes a lot of different entries here. And you have various record types. So let's go over what those are. CNAME is the canonical name. This is saying whenever you contact this domain, this IP address, here is the primary name that you should be calling us by. Next is the A record. And this is mostly used for websites or web services. And it says, yep, if you go to wikipedia.org, here is the IPv4 address to contact. And if you have a quad A record, as I like to call it, that'll give you the IPv6 record and it'll tell you the IP address to talk to. A few other interesting ones is the MX records. This is if you're using email, particularly IMAPI or POP3. Text records, these are kind of a wildcard thing. You put whatever you want into it. In practice, though, most websites use this for search engine optimization. NS, this is the DNS domain server, and this is used for subdomain routing. So if you're going to things like, you can see here, gist.github.com, gist is a subdomain of github.com. And if you want to know how to contact those, this entry will tell you, if you're trying to do a subdomain, talk to this server over here. And usually they'll have multiple name servers. So usually what they'll have is also a record called the DNS zone start of authority. And this is the primary DNS name server to talk to. So if you go into the results we got back, here we go. So you can see here, first number one is the A record. So whenever you go to wikipedia.org, you're actually going to this IP address for IPv4. For IPv6, you're going to this address. The start of authority for DNS says if you're trying to go to a subdomain of wikipedia.org, such as media.wikipedia.org or cache.wikipedia.org, this is the first list of servers you should be contacting. And here's some of the backup ones, NS0, NS1, NS2. MX says if you're trying to send us mail, here is the servers to contact for that. Text, you can see here we have Google site verification. So that way Google can verify that the owner is who they say they are for this website. As far as V equals SPF1, I'm not too sure what those are, but most likely they're also used for search engine optimization. All right. We can also do is look up who actually registered the domain name for Wikipedia. So this command is not enabled by default in Kali Linux. So we'll do sudo apt-get space install -y whois, and this should install pretty quickly. Yeah, it's 67 kilobytes, so it's pretty small. Give that a sec, let it run. Oh, it's coming from Pawnee Express. Nice. So the whois command will show you who registered the domain name. So go ahead and run that. And this is all information coming from the DNS servers that you're hooked up to. And it usually includes things like what is the person's name, what is their address, usually the business address, what is their home phone, what is their phone number, what is their email address, basically just general contact information as far as who the owner is of the domain name. All right, cool. So you can see here, yep, so we have the creation date. So this was made back in 2015, 12/12. I was like updated. It was created in 2001 on January 13th. Expires in 2023. Registered through Mark Monitor Incorporated. Has the INA number. So that's looking pretty good. Sometimes registration information is actually kept generic, which is actually really common, but you can see here domain admin, the Wikimedia Foundation in Montgomery Street in California, San Francisco. Here we go, the admin. Again, you can see it's mostly just generic information. You don't always get useful information from this, but every now and again you will. You'll actually get a specific person's name, address, and phone number. So if you're having any issues with wikipedia.org, much like wikimedia.org or wikipedia.org, you can contact this DNS-admin and let them know about it. Okay. Next up, we're going to look at Traceroute, and this will show you how your packets are going from your computer to the DNS router, to the servers, and back again. Now, as you're running this command, every now and again, you'll see a star, star, star. That's actually totally normal. That either means that the connection is going through is kind of messed up, kind of slow. I'm on my Wi-Fi right now, and I'm doing a video stream, so sometimes it's a little slow. Other times, the servers that are in between just won't even respond back to it. But in general, the servers you're connected to will tell you how the connections have been going. So that didn't go very well. Let's try it one more time. Okay, that's not running for some weird reason. It's probably a network connection with me and the Wi-Fi. Oh well, whatever. When you run it, you should find something pretty interesting for the results. All right, so that's a basic wrap-up of how you do Recon for service. You should look at, get the DNS entries, look at what's there, enumerate some of those as far as IP addresses go, take that, feed that into Nmap, scan that for services. Once you find a service, try to find an exploit for that service or the default user admin, default credentials. You can usually use that pretty easily. Once you actually do have access to a server, even if you're not admin, you can still double check and see if it's running anything for services using Netstat. You can also run PS AUX to see if any other services are running, you may be able to attack. And if you want to verify your local services, you can run PSOX, you can run ping, Ifconfig, Traceroute, and you can also get information on DNS running the whois. So this is just a test video. If you have any information, any questions, let me know. Thank you.